Welcome back to another video, everyone. Welcome back to my channel, and we are going to build upon the negative binary forms. Previously we've done sign magnitude, and we've also done ones complement. If you have not seen the sign magnitude or ones complement, please go do so. And this builds upon more of the ones complement than it does the sign magnitude. So let's just get started. So two's complement, it's another representation of negative binary numbers. So it's the most commonly used representation of negative numbers. One of that is because there's not two different values of 0. For example, in the ones complement, this is ones complement. There are two values of 0. So we have 0, 0, 0, 0, and that would equal plus 0. And then we invert all the ones, all the zeros to ones, and all the ones to zeros. This is just straight zeros, so we just invert them to ones. And then you have negative 0. So there can be a problem in addition and subtractions, which is caused by this type of inverting of these numbers, but two's complement does not allow that. So how do we figure out a negative number, a negative binary number in two's complement? So what we do is we figure out the positive binary form. We figure out the positive binary form, invert all the ones and zeros after the least significant one, and we keep the least significant one 1. We do not invert it. So we are going to do keep the least significant 1. We don't want to keep it 1. So keep the least significant 1. Invert all numbers left of the least significant 1. So what do I mean by that? Let's do something easy. Let's do 11. Let's figure out negative 11 in decimal form, what is its binary form. So we want to figure out the positive form. So let's figure out the sum of power method. 2 to the 3 plus 2 to the 1 plus 2 to the 0 equals 11. Let's use a 6-bit register. So what am I doing here? We have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 1, 2, 4, 8, and 16. I just want to figure out what's the highest number that goes into 11 without going over. 16 goes over, then we're left with 8. That leaves us with 3. So 11 minus 8 leaves us with 3. 4 goes over that 3. Then we have 2 minus 2 equals 1. And then this one minus 1. So we are left with 2 to the 0, 2 to the 2, and 2 to the 3. I want to do a 6 register. So 1, 2, 3, 4, 5, and 6. Add the ones in the placeholders. So 2 to the 0, 2 to the 1, and 2 to the 3. Show those placeholders. So what we're going to do, we're going to fill the rest with zeros. So this right here is plus 11. So how do we do 2's complement? So like I said, keep the least significant one 1. What is the least significant one? This. Keep it 1. Keep 1. And we're going to invert all numbers left of that. we're going to invert all these numbers. 1, 1, 0, 1, 0, and keep this 1. And this is negative 11 in 2's complement form. So like I said before, there's only one representation of 0. Why? 0, 0, 0, 0. Because in 2's complement form, we look for the least significant 1. There is no 1 here, then we can't invert the zeros. But let's say if it was 0, 0, 0, 1, which is the value of 1? This is plus 1, right? Now let's find the complement form of plus 1. Negative 1. Least significant 1, keep this 1. Keep 1. Invert the rest. So it's 1, remember 1, 1, 1, and we keep the least significant 1. But with 0, you can't do that. There is no 1, so you can't invert to the left. And now for plus 6, we have 0, 1, 1, 0. Reason being, 2 to the 2 and 2 to the 1 is 4 plus 2 equals 6. So we find the least significant 1, which is this one, and we invert the rest. Ignore this. Ignore. So we have 1, because you're inverting. 0, you're inverting. You keep this 1, and you just keep this the same. Everything over here, keep the same. So all you care about is finding the least significant 1 and inverting everything to the left of that least significant 1. Everything to the right of that least significant 1, keep the same. So what is plus 19 and negative 19? Just like you do in binary numbers, plus 19 will be the same in every single form. Sign magnitude, 1's complement, and 2's complement. The thing that differs is the negative. It's the way you transform that positive into a negative. So let's do sign magnitude. Sign mag. So 19, what is 19 in binary form? It's 16 plus 2 plus 1, that is 2 to the 4, plus 2 to the 1, plus 2 to the 0. We're doing an 8-bit register. 1, 2, 3, 4, 5, 6, 7, and 8. So that's 1 add 2 to the 0, 1 add 2 to the 1, 2, 3, and 4. 2 to the 4 is a 1, 0, 0, 0, 0, 0. This is plus 19. So this is our first answer. So what is that in sign magnitude? In sign magnitude, all we do is we add a sign bit to the n. We add a sign bit to this n right here. Oops. And 0 corresponds to positive, 1 corresponds to negative. So it would just be 1, 0, 0, and here. Let's erase this real quick. Okay, so I'm just going to line it up for you guys so you guys can make sure to see it. So positive 19 equals 0, 0, 0, 1, 0, 0, 1, and 1. So sign magnitude. Where's my pen? There you are. Sign mag. So we add a sign bit to leftmost bit. So this leftmost bit, we're going to be a 1 because that corresponds to negative, and that's it. We do the same exact thing. Alright, that's it for sign magnitude. You just add this sign bit. You change it. 1 corresponds to a negative. 1's complement. We invert all the numbers in 1's complement. So all the zeros become 1's. All the zeros becomes 1's. And all the 1's become 0. As you can see, these are just an inversion. They're just inverted numbers. And now what do we do in 2's complement? In 2's complement, we find the least significant one and invert everything else to the left, but we keep this 1. So it's going to be 1, 0, 1, 1. Let's see. A lot of numbers to keep track of. 0. Lost my way. So let's do it over here. 0, 0, 0, 1, 0, 0, 1, 1 equals positive 19. And in 2's complement, it's 1. Keep this 1. Invert. 0, 1, 1, 0, 1, 1, and 1. And this is 2's complement. And as you can see, it's not much different than 1's complement. Of course, if it was a little bit more shifted, it'd be a little bit more different. But I'm just, doing a little review over the different ways to represent negative. So what's 72 and negative 72? Figure out 72 first in its positive form. Positive is always the same throughout all three, between sign magnitude, 1's complement, and 2's complement. It's only the way that it's changed. So 72 equals 64 plus 8, which is 2 to the 6 plus 2 to the third. We're using an 8-bit register. 1, 2, 3, 4, 5, 6, 7, and 8. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. A 1 at the 2 to the 6th place, and a 1 at 2 to the 3rd. Everything else is 0. And this value right here is plus 72. And in 2's complement form, we are going to find the least significant one, which is this, and invert to the left. Invert. And we're going to keep this. Alright, so it's going to be 0, 0, 0, 1, and we invert everything else. 1, 1, 0, and 1. So as you can see, this stays the same right here. These stay the same. And then we invert everything else. We invert these 4 numbers, as you can see here. And this is negative 72 in 2's complement. So what is negative 13 in 2's complement binary form? Figure out what's 13. Plus 13 equals 8 plus 4 plus 1, which is 2 to the 3 plus 2 to the 2 plus 2 to the 0. And let's say we want a 6-bit register. So 1, 2, 3, 4, 5, and 6. 2 to the 0, 2 to the 2, and 2 to the 3. 1, 1, 1. Everything else is 0. This is not our answer because this is plus 13. Now we want to do in 2's complement to find negative 13. Figure out the least significant one and invert everything to the left. So alright, this is 1, 1, 0, 0, 1, and 1 is negative 13. Alright, what is negative 53 in a 2's complement? So it's plus 53 is 32 plus 16, we are 48, plus 4 plus 1. So what is this? This is 2 to the 5 plus 2 to the 4 plus 2 to the 2 plus 2 to the 0. And we want to use an 8-bit register. 1, 2, 3, 4, 5, 6, 7, and 8. 2 to the 0, 2 to the 2, 2 to the 4, and 2 to the 5. Have 1s in those places. Fill the rest with 0s. That is plus 53. Figure out the least significant one and invert the rest. Remember, keep that least significant one. Negative 53 in 2's comp equals 1, 1, 0, 1, 0, 0, 1, and 1. Well, thank you guys for watching. If you guys want to hear from me again and see some more computer organization videos, please leave a like, comment, and subscribe for more educational content. Thank you, everybody.